okay, and thank you for attending. As Bashad mentioned, if you have any questions, you think they're appropriate, please raise them. This is really a technology sharing because I learn as well too when giving these presentations from the questions and other material, and that's one of the focuses of this talk as well too, is getting information. So we already went through that. Just starting it off, for those who not started, tribology is a fairly new term. It started in the UK with the 1966 JOST report, and that study found that friction-aware losses amounted to about 2% of a nation's gross domestic product. In Canada, there was a 1986 report by the National Research Council, Associate Committee in Tribology, that over $5 billion is lost annually. That's $12 billion and $26. The report had 10 recommendations that included more research, but also better training and education. And that's one of the focuses of this talk that you'll see. In a lot of cases, there's much improved lubricants or systems or procedures out there, but people just unfortunately aren't aware of them. So there has to be a lot of much improved getting information out to people and coordination between different groups. As to the NRC recommendations, none of them were fully implemented, unfortunately, and the government, in their wisdom, canceled the Associate Committee in Tribology. So we're going backwards, not forwards. How's Canada doing? This is something I got in a Globe Mail just recently. It was very apropos about the problems in Canada. The Canadian workforce is less productive because on average, companies here use less capital and technology and are less innovative and operate at a smaller scale in economy, plagued by insularity, and it's getting worse. That's from the article, and we'll talk about that a bit later as well too, as some of the things that can be done that. What it's also found is one example here is for Germany, some of the things that they've done. I'm not going to read all this one off, but one of the keys is worker training. And that's one of the focuses of my talk as well too, is we have to do more in training. I see it so much that somebody's just dumped into a job with given no training or not even sitting with the person who had that position before, to learn about how to do things, especially in power generation. It might take you 5 to 10 years to totally learn a system, and they're just not given the opportunities to learn. So why should we care? Well, there's all sorts of numbers, and this is one of the things here. I've got a series of maybe a dozen examples of some of the problems that are out there. It might not be your specific plant. You might be one of the lucky ones, but these are based across the whole industry. In particular, most of them are based in North America. That 60 to 80% of bearing failures are lubrication related. This obviously has consequences. It's not just the cost of the bearings. The bearings really don't cost much. It's the downtime and the outage and replacement costs. And also, every time something fails, there's a chance of then infant mortality when they put it back in. As well as every time you pull a bearing in and out, you can be affecting fitting. So there's all sorts of consequences. And this can affect your job, and again, it can obviously affect you. What else are we doing? Motor failures. The main problem with the motors aren't necessarily electrical. 50 to 65% of all of the motor failures were because of the bearings, and poor lubrications practices account for most of these bearing troubles. In an EPRI study, they found that more bearings were failing from over lubrication than under lubrication. When you first grease the bearing, the temperatures will go up. And sometimes the operators might say, well, stop lubricating, it's getting too hot. Well, no, it should go up, but then it should come down. But if you over lubricate it, or if there isn't a place for the grease to go, the temperature won't come down and it will churn the grease, leading to grease failure and bearing failure. So this requires certainly proper maintenance procedures, but also planning and the use of the correct lubricant to increase productivity and by reducing these bearing troubles and motor failures. How else are we doing? On pump failures. Here, I'm not going to go through all of these things, but you see 90 to 95% of those failures could be preventable. Solid contaminants can be preventable with better seals. Unsuitable lubricant, again, that's preventable just by doing the right checks in the first place. Aged lubricant, what are they doing for condition monitoring? About 80% of bearings are grease lubricated, but almost no plants monitor their greases or test them. And there's simple devices out there like called the grease thief or things like that. You can test the grease to see how they're doing. In some cases, even on nuclear plants for motor operated valves, they just have little plastic bags full of different greases of different consistencies, and they just use tactile testing and color testing to determine whether or not the grease needs changing or not. So there's a number of very simple things that can be done, but something should be done. How are we doing on rolling element bearing failures as opposed to just bearings in general? This is one of the biggest things that is most concerned to me as a professional engineer. Only 3% of the bearings reach their design life. That is, that they fail by subsurface initiated fatigue. That's unfortunate. So when somebody says, oh, we have an LTNH life of 60,000 hours, they don't get there because they're murdered earlier for a number of reasons. And you see there. In this one example, SKF said 50% were because of bracelet wear. That's just bad seals, or it could also be contaminated lubricant. They found that 30% failed from marginal lubrication. That would typically be under lubrication, and 17% from other. So there's things that can be done. Do we design correctly? Bearing fatigue lives, this is something certainly all engineers get when they go through. Hopefully they're using the adjusted rating life now, that ISO factor, the life adjustment factor based on the new life theory. They have to take that into account, and I'll show it in a second. But the things that affect the bearing life, this is the L you see on the side there, for millions of revolutions. Normally it's L10. Now L10 means 10% of the bearings will fail within that period of time. If you want a higher life, you have to go to like an L5 or L1 if you want 10%. Unfortunately, that usually means you have to increase the size of the bearing. That might force you from grease lubricated to oil lubricated. You might have to put in cooling, things like that. So you're much better off trying to allow the bearing get to its design life by improved tribological practices. Well, what's some of these? First off, the A ISO factor takes in apart degrade of contaminants by a factor EC, and using the lubricant as supplied based on a typical contamination code, it can reduce the life by 50%. Especially for rolling element bearings, when the oil film is just microns thick, you have to use the proper and clean lubricant. Are we getting better? This was from a presentation given in the Hamilton section by SKF. Again, they found that the bearing failures in this case were poor fitting. That's from installation. We'll talk about that a bit briefly later. Poor lubrication at 36%, 14% by contamination, and fatigue 34%. Fatigue in this case can be both subsurface fatigue and surface initiated fatigue. Surface initiated fatigue is the pits and spalls and things you get sometimes from installation, from false Brinelling, or it can also be from contaminants in your lubricant. So we're still not doing particularly well. Do maintainers and fitters have the right equipment? At the time I was doing a maintenance helper up in Timmins, we were basically told, well, if you hit a bearing with something softer than the steel, it's not going to hurt it. So we used wood, that is fibers, or bronze. That's just not right. The companies have to spend the right money to give them the right mounting tools. And this is one reason why. When you're installing the bearing, especially when there's a force fit on the outer housing, and usually a sliding fit, you don't want to put the force on the inner ring through the rolling element to the outer ring, because that causes Brinelling, which is an indentation, which would then lead to failure. Again, very, very simple, but people have to be trained how to do it properly. To get to put in every time. This is a calculation that you can go through, and in this case, it came so you needed 33 grams of grease, which is 1.2 ounces. With this typical grease gun that can put out 10,000 psi, and that's correct, 10,000 psi for the typical grease gun. Some are even higher, and that's why the grease has to have someplace to go, because you can damage seals, and if there's shields or seals on the bearings as well too. That can take 43 strokes. One plant I knew was having difficulty with their greasing, so they said, well, each bearing's only going to get 3 shots of grease. That's absolutely no good at all. You have to know how much to put in. The difficulty is you don't know what's been done in the past when you walk up to a piece of equipment, whether or not it was done properly. And how does the person know to put in that many shots of grease? Look at the grease gun? No. Most grease guns, it doesn't tell you how much they deliver. The information is on the package, which is not kept with the grease gun. This particular grease gun is also a dual type, but it has dual delivery to further complicate it. Outputs 5.2 ounces with 100 strokes. So again, people have to know how much grease to put in. You can't just pump it till you get resistance. Remember, that was 10,000 PSI. So you don't want to do it that way. What do you do? Fortunately, there are a number of devices out there now, especially using ultrasonics. There's a number of things that can be done that know how to do it properly. You don't give greasing to somebody who has deficiencies or impairments or unable to do some other job. You wanted to give it to somebody who's been trained to do it properly and that you've given them the right equipment so they know how much grease to put in. Now, just a little bit of particle counts. I'm going to go through this briefly. It's a little bit complicated, but it actually counts the particles at 4, 6, and 14 microns. It used to be 5 and 10 microns, but then they found the AC fine test dust wasn't the size they thought it was, so they came up with these codes so you could try to keep the same numbers. But they basically look through, if you go through here, say you end up with 1,000 particles of the 4 micron size, that comes between these two numbers, so that code would be a 17. So a 17, 15, 12 means that. So that means that the 4 micron size, there's somewhere between 640 and 1,300 particles. Well, why is that important? This was some work done by Noria and Dr. Fitch at Oklahoma State University down in the US. It shows that if you start with on the left there with a 22, 2017, and you improve it to a 15, 13, with a gearbox, you can actually improve the life of the gearbox by 3 times just by using a little bit cleaner oil. And this you can go through all sorts of other categories as well too, whether it's servo valves or things like that with hydraulics, 17, 15, 12. You can go across to how much you improve it, how much you might increase the life. This has huge cost implications and savings. So you have to spend a little bit of money to get some of the proper filtration equipment and maybe some of the proper handling equipment. But more and more companies are understanding the importance of having clean lubricant and keeping it clean. Most oils do not wear out. They get contaminated. There are some differences in there with motor oils, things like that, and certain additives, but usually the issue is contamination, and you want to prevent that. In hydraulic systems, just another example there, more than 3/4 of all the problems can be traced back to contaminated oil. And that's something you can see, especially on hydraulic equipment working in dusty, dirty environments. If their rod seals, aren't working properly, things like that, it gets into the oil. So you have to stop it getting in, and when it gets in, you have to try to keep it out. But generally, it's a good idea to try to stop it getting in the first place. The interesting thing on that too is particularly monitoring hardware, for example, temperature and vibration and things like that, doesn't necessarily help you with contamination until it's too late. If you get a spall on a bearing, it has to get big enough before other vibration, other types of method can pick it up. So you're better off keeping it clean and testing your lubricants. What can we do for better seals? Lip type seals have a limited life. O-rings are not good as dynamic seals at all. They're good at static seals. But even lip seals, their life might only be 8,000 hours. For an automotive bearing, that's okay. That's a long time. But for something running 24/7, that's not good enough. And it's also much better off having a non-contact type seal. In this case, one part rotates through the shaft, the other part is stationary, and it keeps the lubricant in and just keeps the dirt out. Plus, because it's non-contact, it doesn't generate heat. A lip seal will generate heat just because there is friction. Now, on the real world, this was an example of centrifugal pump failures. They found that 43% of the failures were because of improper operation. We had a little discussion before with Peter from the Alberta section. They had a talk yesterday from Crane on buffer fluids, how important it is. And in a lot of cases, it's just as simple as making sure that there's the right pressure for the buffer fluid. So that's keeping the process liquid out of the seal. In this other case, they found maintenance deficiencies were 17%. 14% were assembly or installation errors, and 24% they were running it off design. That could be with a throttle pump, or in a lot of cases, it's insufficient suction, but there's a number of things. Again, as was mentioned with the earlier bearing type failures, a lot of these are preventable just with proper awareness and training. This is what that one station did, the plant did that had those failures. They reduced their failures considerably just by a little bit of training and awareness. They didn't spend anything on more equipment. So again, huge benefits just from an improved awareness. How hard is it to do it right? Well, if you want to prevent grease contamination, the one thing is color-coded caps, and people have done this. You can get grease guns now that have a clear case so you can see what the grease is, or some people paint them or put codes on and know what they are. You can also have grease caps. You should have these grease caps anyways, because one of the worst things when you go into a plant, if the grease nipples are all nice and clean, that's bad because you get dirt sitting in around the ball inside the dirt fitting. These so leave a blob of grease on it so people can see the color, or use a color-coded grease cap. You can also have little pressure relief things that relieve pressures if the pressures are too high. The other option is screwing the Zerk fitting out so the grease has somewhere to go. It depends on your situation as to what you can do. So what are some of the things that can be done? This actually goes back quite a while. It's based on an International Atomic Energy Authority thing on information strategies, tools for condition-based maintenance at nuclear power stations. And they talked about about the importance of training, skill standards, and certification. And this is very, very important. There's a number of places out there that are offering training now for lubricators. STLE has the CLS, and also the analysis courses and the different types of courses for certification. But for people in the plant, there's probably the IML ones that are very good as well too, to give people a little bit of understanding about what you can mix, about different greases, and what can be done. But it is important to have training. You should have in your company at least one subject matter expert, some we call SMEs, and hopefully some supporting with training for your fitters. Unfortunately, at some stations that I know about, once they hire a fitter, they never give them any training for the rest of their career. That's just totally backwards because technologies have changed. A lot of things have changed. For example, just looking at your car, how often do you change spark plugs these days? They don't. They almost last the life of the vehicle rather than having to do them every year. You can get the same improvements on some of your plants and equipment as well too by using newer technology without spending a lot of money. The other thing that's big these days that Canada seems to be a little bit far behind again is getting registered to ISO 55,000 on asset management. I'm not going to go through these, but there is a reference, but I suggest you look it up and hopefully your company is trying to implement that. Again, that's something you looked at later. What can you do? You can often take advantage of many of the green attributes, and that's something I use to advantage when you look at some of the corporate statements on sustainability or other things like that, as to how you can have a green attribute. One of the things President Obama did was one of the things for his thing for energy was if you could use less water, for example, if you needed less cooling, that was then a green attribute. And sometimes you can go to a different lubricant that then doesn't need cooling and that doesn't need water. That's an advantage. But it also could be sustainable. It could be that it lasts longer. That's can be an advantage as well too. Generally, the better oils and greases do last much longer, especially if you can keep it clean so you don't have to do the changes. It can be less toxic, and that doesn't mean it just drops dead, but it can be less impact on the environment with some of the different additives and different lubricants. And if you use, say, a high viscosity index oil, and I'll talk about that briefly later, there might be no seasonal changes. So again, there's savings there. There can be less required for a variety of reasons. It can be less volatile, or if with better seals, there can be less makeup, so it's not leaking. If it's not leaking, then it's not also a fire hazard, it's not collecting dust, it's not a slipping hazard. There's all sorts of benefits that can be used. Less makeup is obvious as well too. They're not having to go and do it. There's also reducing the chance of somebody adding the wrong thing with less makeup if they don't have to do it. Less friction is also easy as well too. Sometimes just going with a little bit better product, and I'll mention that briefly with some of the new API SN oils as well too for energy conservation, and with better additives as well too. There can also be less wear. Um, Less energy has 2 points as well too. That obviously with lower friction, some of the other advantages, they also can be less energy. That can show up from the power required to drive the equipment, but it could also mean if something with it warms up faster, for example, a high viscosity index oil on an outdoor hydraulic piece of equipment, it warms up faster. So you're wasting less fuel on the startup to get it. So there's a whole bunch of ways that you can save money. Obviously, some of these products are, safer as well too, and there can be lower disposal costs. There's all sorts of ways that you can help your company save money, and the net result of all this, should be lower life cycle costs. That's what you also want to achieve. Just an example of why it lasts longer. I sometimes found that people said, "Oh, well, if the oil is dirty, we'll just change it." It's amazing how much it really costs to change oil when you take into account all the things. If you want to, you can go to some of the references to find all the details. But in that case, I went through, it was for a nuclear plant, but you went through all the things it took to get the lubricant. If you're adding a liter of oil, it doesn't just magically appear. Somebody's got to go get it. It's got to be stored. It's got to be stocked. It's got to be purchased. It's got to be checked. It's got to be tested. When you drain it, it's got to be tested, certainly for chlorine to make sure it's not PCBs. It goes off for waste disposal. There's all sorts of costs. In this thing, the cost came to 40 times the cost of the new oil. So if you can get something that lasts longer, takes less changing, there's obviously huge benefits. In this case, on the one product that was mentioned earlier that I helped develop for motor operated valves, by not having to pull out a motor operated valve inside containment, things like that, was saving them over $7,000 a year. So just by having a grease that was able to last 5 times longer, they saved tens of thousands of dollars. And the new grease, a standard grease, give me an example, might cost $5. A really good grease might be $10. So it's twice the price, but it saves tens of thousands of dollars. So engineers and people have to get used to looking at cost justification. Now, just a little bit briefly on viscosity, we're seeing a lot more of it these days, especially now with zero W16 oils, and they might even keep going down. The focus being that on energy conservation, because there's less losses, churning and friction and wear losses with the lower viscosity oils. They still work just as well, providing that the engine is designed for that. But again, most engine wear occurs on startup, not during normal running operation. So if you can reduce the startup losses and reduce the startup wear, you're getting much, much longer engine lives. And even with these 0W16 oil, 0W30, even 5W30, engine are still lasting hundreds of thousands of kilometers if they do the proper oil changes. So what does this mean? This has an example not just for engine oils, but also for hydraulics and things I was mentioning, or any outdoor equipment. If you have a higher viscosity index, it's better at the low temperature, and it can also be thicker at the high temperature. So there can be huge advantages with an oil with a poor viscosity index that can both get into problems when it's too cold and problems when it's too hot as well too. Often huge benefits to using the right oil in these cases. I often find a lot of cases people or plants were pushing, oh, we have to reduce the number of lubricants we use. Yeah, no, that's great. But what does it cost to stock one lubricant? And I'll give on some of the examples later. We found where specialized greases, for example, save tens of thousands of dollars because they were needed. And this just to show there's no such thing as a universal grease. They have pros and cons. So you have to look for that particular application as to what's is needed and whether or not you can get some of the other benefits and what it actually costs to stock one extra grease. I could never get that information from some of the companies I talked to. They said, oh, well, we have to reduce down to just 2 greases for the whole plant. I said, well, what's it cost to have 3? Well, I don't know. There has to be rationale. Let's start at home. This is something I just dug up with these new SN oils type things. Um, they're generally required for turbocharged engines protection against low speed pre-ignition, LSPI. So certainly if you have them, you want to use the SN plus oil. But the other thing is now there also is oils out there that are energy conserving that you can buy to improve the fuel economy. And they say they can save 1.5% or greater over the standard reference oil. So even if you're just buying the oil for your car or for your equipment, if they have an option for an energy conserving one, use it. There's also for engines with a lot of miles on them, you can get high mileage oils that have a little bit of ester in them as seal swell. You don't want to use it on a new engine, but again, the benefit is it reduces leakage, reduces oil loss, reduces contamination, and reduces oil makeup. Again, huge savings just by using the right product. Now, this is just some of the things, there's some of the examples that I talked about a particular type grease. This goes back to a presentation that was actually about 40 years ago now about special couplings for greases. I remember the presentation at Toronto section by a fellow from Kodak. I'm sorry, I forgot his name, about the need for specialized coupling greases. This is for gear and grid couplings in particular. The problem is because when the shaft is rotating, the centrifugal forces would cause the oil to separate from the soap. The soap would migrate to the outside, and in most cases, the soap has no lubricating capabilities, and so the gear teeth would fail. But by spending a little bit more dollars for the grease, they could save hundreds of thousands of dollars on not having to change out the coupling. Because the coupling is not easy. You have to pull it off the shaft, often by heating it up or by using hydraulic mounting, things like that. And there's damage either way, and it's replaced, but there's also the downtime. So again, just using a right lubricant when it's needed can save a lot of money, and it's easy. Is it worth it? This was an example on a problem with some steam turbines that they were having vibration problems at high speed because of they're lightly loaded. Um, Steam turbine bearings are generally over designed to allow for loss of bearing type situations. But if they jack them up with the preload to stop the whirl at high speed, so it would get wipes at low speed. In this case, it was about using a pressure dam type bearing where they could just modify the top half of the existing bearings, and that solved their problem on the half speed whirl. Again, it only costs about $20,000 a bearing, and an estimated to save over $4 million. Again, easy if you know about it. How do you know about it? Go to meetings. Is it worth it? This was an example of a advantage of a slightly just changing a steam turbo oil. Most of them now are group 1 and group 2, but back then there was a lot of group 1s. But the problem was that people are aware of the pour point of oils. They're not aware necessarily of the cloud point. The cloud point is when the wax crystals first start to come out. And in this case, because the oil cooler was mounted on the outside wall, in the winter, wind would chill that oil inside the cooler, so the wax would start to come out. And when the pumps would start up, it would push that wax to the filters, which would cause too high a pressure drop and cause a trip. So that wasn't good because a lot of these things were emergency power generators and things like that, standby power generators. If you have one failure, you then have to have so many successive failures. But just by switching to a steam turbine oil, from a that was severely hydrotreated, solved the problem. What else can be done? This was an example of using a polyalpha olefin in a coal pyrolyzer gearbox. The payback period, just because of energy savings, using the same viscosity, not even dropping viscosity, was only 122 days. Huge savings. Unfortunately, it wasn't done because the maintenance department paid for the oil, but operations got the benefit. That's not uncommon. As to for improvement, who's going to pay for it? And that's one of the systemic roadblocks in a lot of cases to a tribological innovation. It's not too late. What can we do? Certainly, from my point of view, engineers have to be taught a lot more, and MBAs as well too, about return on investment and life cycle costing. Also, root cause analysis should be part of design courses. When you're learning about pumps and hydrodynamics, learn about pump failure analysis, learn about bearing failure analysis, seal analysis, and the things of how to do it. We also have to get MBAs, and management need to be more aware of the benefits of life cycle costing with respect to asset management and tribological savings, especially at plants. We were talking about some of the things. Why is Canada behind others? I don't know why supervisors don't necessarily ask their employees, well, what can we do to do our job better? And you can go the other way as well too, encouraging employees to make suggestions to improve things. And number 4 there, in a lot of cases, asset management and ISO 55000 can be the key to start doing things better and to get companies. And again, I think the federal government could help there too by making sure their suppliers are registered to ISO 55000. Everybody's big on quality assurance, but why aren't they working on asset management? So the last point there is continuing education. Especially in engineers, what you learn at school is only in a lot of cases enough to be dangerous. You have to learn how to apply that knowledge properly and to prevent failures. And that often becomes after graduation. And I know that was certainly true in my case as well too, where I picked up a lot of those information from training courses and other seminars that I went to. And I had a supportive management to get involved in those things. Again, management is key. So summary, most bearings do not reach their design life. The leading cause of hydraulic system failure is contamination. The leading cause of electric motor failures are the bearings. In my opinion anyways, many failures can be easily prevented, and it can be easy to do better if you know. For example, just changing to a slightly different product as well too as a lubricant. But unfortunately, the work environment must be conducive to change and be receptive to life cycle costing savings. And training is an investment in your employees and in your plant. So this needs to change. That's another quote that I got just recently as well too. This is referred to banks, but I think it applies to a lot of companies. Buffett said that more banks will fail over time because managers continue to do dumb things at times to boost short-term profits. And I see that as well too. They're trying to reduce costs on things, and sometimes it's just arbitrary. Well, we're going to reduce costs by 10% without thinking about the long-term consequences. So that's it. So hopefully you've enjoyed that, and now there's time for some questions.
Thank you very much, Ken, for sharing it with us. I don't have any question in the chat, but I think we can open the floor for anybody who wants to raise the hand or unmute and ask the question. Um, from my side, I know that you have been working and thinking about the best way to measure or calculate the base oil viscosity for the greases which are lubricating the bearings. Just wanted
Mhm.
to know if you found something interesting to share with us before anybody else asks the question.
Sure, maybe just give a little background. One of the things when you're doing bearing life calculations is what viscosity to use for the grease. Most people suggest you use the base oil viscosity of the oil in the grease, but that's not the same because the grease actually has an apparent viscosity, which is much, much different. One of the better answers I got that, well, one person said that, well, we have to use the base oil viscosity because if the grease shears down, that's what it's going to shear down to. And that's true certainly of some things like polyurea greases and things like that have very poor mechanical stability. For other greases, you might want, especially for higher speed applications, use the apparent viscosity. For low speed applications, um, again, because the thickener isn't involved, again, you might want to use the base oil viscosity. So unfortunately, beside there wasn't an easy answer to it because it depends a lot on the grease itself. But it comes down to when you do get a bearing failure, having a look at it or determine whether or not your grease is lasting as long as it should be. The reason being is just you can not only change the base oil viscosity, but there's also the NLGI grade, which is the consistency. Most bearings use a grade 2, but if it's a lower temperature application, you might want to go with a grade 1. In a few cases, even a very, very softer grade 0. In other applications, if it's vertical, for example, you might want to go to a stiffer grease, like a grade 3, NLGI grade 3. So it really does vary, but people just have to look at whether or not they're having problems with their current equipment or what improvements they can make. The disadvantage of using too stiff a grease is, again, you increase the friction losses. And so the bearing temperature goes up, and so the bearing's sort of self-sealing. It will generally warm up enough so that the grease thins out until everything balances. But that's not good because, as you know, as higher temperature, the thermal oxidation life becomes shorter. So it has pros and cons. But just if you want to improve bearing life, there's a lot of different things you can do these days. Almost everybody uses double vacuum arc mounted steel these days. But SKF, for example, has a new steel that they claim you can increase the bearing fatigue life by 3 to 8 times, depending on oil film thickness, just by paying a bit more for the bearing in the first place by using a better steel. That assumes you're not murdering the bearing because of improper lubrication and contamination.
Mhm.
Okay,
Uh,
I see a message there from Henry. Do you want me to read it, Bashad, or
uh, I don't see that. I think that's he sent it to you directly. I don't see it in the
oh,
chat.
okay,
So.
yes, see. Okay, Henry Kemp said, what are the recommendations with regard to ongoing training, education of engineers, technical advisors, technical sales staff? Well, good. Certainly there has to be some. Engineering, I'll start with, that's fortunately the most difficult because there is an engineering qualification board that determines whether or not a university, their training allows them to be registered as professional engineers, and they're focused too much on books. I don't know how to change that, unfortunately. When it comes to certainly staffing and things like that, it's enough to make sure that you have the people doing your lubrication are properly trained on to do something. That could be a half-day course or one-day course, whether it's the ICML courses, they're being offered regularly, as well as when I first started off at the STLE annual meeting, I took a number of education courses. I remember doing the ones on bearing lubrication and synthetic lubricants, and things like that are a great investment. Your oil company supplier will often come in as well too, or give webinars, to you. Um, just with regards to webinars, just be careful about some of the YouTube stuff. I wouldn't say there's a lot of junk out there, but there is some. Make sure it's from a credible source. But again, you need some training for your people. Engineers in Ontario and Quebec now have to take so many training hours a year. So that's being forced to start to do things. But there's not a lot of companies, jumping in and really offering much yet.
Perfect. There is a question in the chat. John says, "Our auto engines are running with synthetic oils now?"
Or what? Auto? Well, it
Auto
depends. It
engines, yeah.
depends on it depends on your manufacturer. If you've got a Corvette or a Porsche or a fancy car, yeah. But it depends what you also call synthetic, because the definition down in the States is different than in Canada. In the States, a severely hydrotreated oil is also called a synthetic. Generally, you want at least a group 2 or group 3, or a synthetic. I personally use full polyolefin full synthetics in my vehicles, even though one's got 350,000 kilometers on it. But the key is the proper oil changes as well too. And if you've got a turbocharged engine, make sure you're using the GN plus to stop the carbon deposits and the pre-ignition difficulties. But the key is oil changes and doing it based on your driving habits. The easiest thing for a car is a lot of highway driving. The worst thing for a car engine is short distance driving, where the engine never gets warm enough to burn off the oil, and it just sits there, and that can lead to corrosion inside the engine, in the bearings in particular.
Great, thanks. Solongo wants to know that why are companies slow to implementing ISO 55000? Is it more costly to get certified than 9001, 14001, and or do they view maintaining it as time consuming?
Well, I think there's two difficulties. One is I see a lot of people on the board and management these days is they don't seem to promote from within. They pull in from another company, another industry usually. So often they don't know the equipment. And a lot of people think an oil is a grease, and they just don't know. And that's one of the things. I have a number of people of MBAs. I ask them, how much time did you spend on life cycle costing and energy improvement and asset management? Zero. I don't want to just pick on the managers and things. I guess you see the same thing in doctors. How many courses, how many hours do they spend on nutrition? I think it's one lecture. It's just,
Hmm.
we got to start thinking the long term. And for some reason, we don't do that. Maybe it's the focus wasn't this. It seems like we combine the worst of the American system, where everything's based on the stock market price, and the worst of the British system, where everything is top down. So people don't do anything unless they're told, and that's just not right.
Okay. I have a question related to my first question. I hope it's not too detailed. When you say use the apparent viscosity for the grease selection, apparent viscosity is like a lab test, and it comes, I believe, in different nozzles and different temperatures. So which
Yep.
one you think would be more representative of real world in the lab?
Well, it depends on the application. It's the same thing. That was one of the things that I was developing that biodegradable grease or hydroelectric stations. Ontario Hydro back then had a requirement for viscosity at different velocities
Mhm.
because they were worried about grease line plugging and also problems within the bearing. So you have to look at the rate of shear, as well too, and see what works out best for your application. But quite honestly, people doing the calculations using the base oil viscosity has worked for decades,
Mhm.
as long as they've got it right in the first place. But because most bearings fail for other reasons, um, you're better off preventing those failures. That doesn't mean, any grease is good enough. You
Mhm.
just have to look at the specific requirements.
Okay. Okay.
Yeah, Ken or Bashad, it's Peter here. I would
Yes.
like to make a comment on doing those calculations. I recently had to do some, in 2 cases actually, and it was with a grease that contains a polymer. So we publish the true base viscosity, but we also publish the the apparent viscosity, so the base oil plus the polymer. So you do the calculations. I did them with both. It's quite a bit of difference between them.
Oh, no, it's huge difference. Yeah.
Yeah, but the additional problem that I'm struggling with is, what do you actually use? Because I've heard that it is not exactly know how much of the polymer will end up in the base oil.
Well, it's
So
also when the polymers are used to how shear stable they are.
yeah,
Because
that
if
too.
they
Yeah,
shear down and surface as well too, that's why people would say, well, if they're going to shear down, we might as well use a base oil viscosity to protect it in the long term. It just means you're going to have higher temperature, initially until it
yeah,
starts to shear down.
right. Yeah, no,
But it shouldn't necessarily mean it's going to fail. One of the difficulties is when people go to too big a bearing. Bearings also have a minimum load requirement as well too that people don't necessarily look at, because if it goes from the unloaded zone to the loaded zone, if it's not enough load in the first place, you get ball smearing because the ball's not don't rotate. So people think sometimes by going to a bigger bearing or too high a viscosity is actually advantageous when it can be a disadvantage.
right. Yeah, yeah. Okay.
So there isn't an easy answer to that one. It just you got to um, get your eyes on the field and see how it's doing,
Yeah.
and hopefully there's not an early failure.
Mm-hmm.
But generally the difference is going to be, if you're monitoring the grease, you'll see it, especially with the ultrasonics. You'll see the output changes.
Yeah, that's the thing with us. We most of the time we don't see that because we're not there.
Yeah, yeah.
Okay.
Well, not everybody's doing it yet either. They're still going by go and give that bearing X number of shots of grease, and you don't know how it's been done. Or the other thing I didn't get into because there wasn't time is the relubrication intervals. How to determine that. There are some rules of thumb. In some cases, it's based on especially if you look at motors, you look at that and don't want to pick on one manufacturer, but they would say, for this size motor, this speed, grease it every 1 month or every 6 months. That's grease technology from 40, 50 years ago. So if you're using better base oils and better greases, well, that stuff's just not applicable anymore.
Yeah. Mm-hmm.
Good.
So the more you know, the more likely you are to give the right answer.
Yeah.
That's good. We have a couple of items on the chat. Lauren says, I thought it was interesting you mentioned equal density coupling grease. Is there a resurgence of interest in greased coupling requirements and benefits? I think he means like a factory field couplings with grease, something like that.
Oh yeah. ASTM has a specification for coupling greases. Falk, for example, gives you an extended warranty and extended life if you use a special coupling grease. Yeah, there's a lot of information out there.
And you see like in the
Just Google
future,
it.
just in the
Well,
future, factory field couplings will be available in the market, like bearing, factory field bearing?
no, you can't factory fill a shaft coupling because you have to often heat it up to mount it or to take it apart. So you would normally mount the hub first. If you have a spacer, you have to install the spacer, and then you pump the grease in.
Okay. Okay. So Payman says, based on your experience, what is the best strategy for convincing managers to accept training as an investment? Ken?
Well, silence means I'm thinking. It only depends on how receptive the boss is, but it might be by trying to pick up something that you learned at some place and how that saved the company money, and saying, well, if more people could learn how to save the company money, that would be to your benefit as well too. That's unfortunately where ISO 55000 comes in. Where to get registered, they have to have a training and certification program. They're forced to do it, and unfortunately, that might be something that's might be required by the federal government when they get off around some of these other issues they're trying to deal with, and just start encouraging their suppliers to be registered. Everybody accepts being registered to ISO 9000. Why not some of the other standards? It just makes sense, economic sense.
Okay. Good. So I don't have any other questions in the chat. If in the room anybody else has a question, please unmute and ask.
Or if something comes up later, just send an email to Bashad.
Sure, sure. And as I said,
So-
we will upload this into the YouTube and the company website, I mean, the STLE website. So you can go and look at it if there is any question or something like that, or contact me or Ken Brown for more details. Okay? So Ken,
Okay, thanks for listening.
do you have anything else to add before we close the meeting?
Well, I guess the one comment gets back to the question is, how do you convince people on training? And one thing is, obviously the people who watch this are more the people who agree anyways, or are more receptive to it. What you have to do is get the people who weren't watching.
That's right.
Watch. And supervisors have to start asking their employees, what can we do to do better? I'll give you an example again. Well, I guess I got a bit of time. Again, at one company I was at, I tried to get them to save the bearings they took out so I could come and look at them. They wouldn't do it. Then they would have a failure analysis report. And one of the last things on the sheet was always, could this failure have been prevented? In every case, they always said no. Oh, sorry. In every case, the answer is yes. Just how much does it cost to do it? So in some cases, I wouldn't say it's union. Employers are worried, well, if we stop failures, we want failures to keep our job. We need this, we need that. But they're in competition with the rest of the world. They have to get better. And that's as a Canadian. So we got to get better. And it's easy. We have a very highly educated workforce, theoretically, based on high school and college and university. Like, let's start using something.
Perfect. Okay. Thank you very much for sharing your knowledge with us, Ken. On behalf of STLE Board of Directors, I thank you. Thanks for all the audiences, and have a great day.
Okay, thank you.
Thank you. Thanks. Bye, everybody.